Analysis of a compound containing only carbon and bromine revealed that it contains 6.99% carbon and the rest being bromine. What is the empirical formula? The first thing that I'm going to do is I'm going to notice that I don't have a percent for bromine. However, I do know that percents need to add up to 100. So if I just subtract 6.9 from 100, I will get my percent of bromine, which is 93.1. Then I can go ahead and do percent to mass. So 6.99% will turn into 6.99 grams. Actually, I want to label my columns first. This is going to be for carbon, and this will be for bromine. So 6.99 grams, and then bromine will have 93.1 grams. Then I can move forward. So I have percent to mass. Now I need to go from mass to mole. So I will divide both by their respective masses from the periodic table. Carbon's mass from the periodic table is 12.011. And bromine's mass from the periodic table is 79.904. I'm going to want to maintain as many decimal places as possible here to maintain accuracy. So I've done percent to mass, mass to mole. Now I need to divide by small. My small is going to be the number from carbon of 0.5744733399. Anything divided by itself will be that thing. For bromine, I'm going to get a number that is going to be close enough to 2 that this doesn't need to be multiplied to find a whole number, so I can just go ahead and attach them as the subscripts. The compound from the previous problem has a molecular mass of 515.46 grams per mole. What is the molecular formula for this compound? So first up, I'm going to find the molar mass for the empirical formula. Carbon has an invisible subscript of 1. Its mass from the periodic table is 12.011. Bromine has a subscript of 2. Its mass from the periodic table is 79.904. 1 times anything is that thing. 2 times 79.904 gives me 159.808. When I add those together, I will get my empirical mass of 171.819. And to find my molecular formula, I will be dividing my molecular formula mass, which was 515.46, by my empirical formula mass of 171.819. This is going to give me a number that's close enough to 3, so that means all I need to do is multiply my subscripts by 3, and that will be my molecular formula. So originally we had carbon with a subscript of 1, so that will turn into a 3, and bromine with a subscript of 2, so that will turn into 6.